Good afternoon. My name is Cristina Vasquez, and my presentation focuses on the trace metal and copper dynamics in a tropical small mountainous river in Costa Rica, the Reventazon-Parismina Basin. The Reventazon originates at Tapanti National Park, while the Parismina River originates at the Turrialba volcano. Both rivers converge nearly 4 kilometers before the estuary area. The basin coverage is 2,800 square kilometers. The annual discharge is around 150 cubic meters per second, and the average temperature is 25 degrees Celsius, with important variations relative to the river sections. The geology is mainly composed of volcanic and sedimentary rocks dating from the Eocene to the Quaternary. This basin covers 5.2% of Costa Rica's territory, produces over 38% of the country's energy, and have been identified as the second most polluted river in the country. We collected 10 water and fluvial sediment samples over a 2-day period with a 147 kilometers linear distance to the estuary and an elevation slope greater than 1,000 meters between sites 1 and 10. We identified trace metals from both geogenic and anthropogenic sources. Extreme vanadium and silica inputs reflect the volcanic rich derivate leaching into the mainstream. Copper, nickel, arsenic, and molybdenum are mainly sourced from geothermal fluids and volcanic derivatives. In contrast, zinc, cadmium, and cobalt relates to the zinc-based fertilizers of the banana plantations. To determine the process involved in trace metal cycling and isotopic fractionation, a high correlation between the dissolved copper and the dissolved organic concentration, or the AMN ratios, suggest that the increase of copper downstream corresponds to mineral dissolution and organic complexation, with limited agricultural input. But also there is the influence of anoxic conditions in the dam reservoirs. Conversely, the copper isotopic fractionation is mainly influenced by human activities. The Reventazon-Parismina is highly affected by soil overexploitation, agrarian and domestic waste, and eutrophication. A relevant finding is the correlation between copper and the ECRs distribution. These water hazings have been reported to enhance bioactive metal absorption in polluted tropical rivers. When we compared with other global rivers, we found out that the molar concentration and isotopic ratio of copper in the Reventazon actually resembles that of the Nile, that it's also affected by the ECRs. In conclusion, the copper dynamics are affected by both natural and anthropogenic contributions. The Turrialba volcano greatly influences copper concentrations. Bioactive metals are also mobilized into the Reventazon water by organic matter, and the mixing of end members in the dissolved phase reflects human activities. The full study will be available soon at ASLO Limnology and Oceanography Letters. Thank you very much for your time, and please contact me for further details or comments.